data within it. Before we dive deep into sets, I would request you to please subscribe to the channel and also hit the bell icon so that you're notified every time we go live. And we are covering an amazing set of concepts in Python from scratch. So even if you're a beginner, you will find this very easy to follow. So make sure you are going through the videos. Any issues or questions you are facing, feel free to put them in the chat. All right, so let's get started without any further ado. Okay, so this is a Python notebook, right? And if you don't know how to open a Python notebook and how to install it in the first place, make sure you're watching the video where I'm explaining step by step how do you download the Anaconda distribution and how do you actually open up a Jupyter notebook where we are actually executing the Python code, right? So if you're not sure how do you actually open this, make sure you're watching that video. All right. So the first step here, what I'm doing is I'm increasing the width of the Python notebook, right? And this is making the width to be 100%. Now, coming to today's agenda. Today's agenda is to discuss sets in a lot of detail, and we'll be discussing two types of sets. One is the regular sets, and another one is the immutable version of set, which is called frozen set. So we'll talk both about sets and frozen sets. And how we will go about this is we will first do a quick recap about what sets are. We will look at some operations which help us create sets and frozen sets. Then we will learn about adding elements to the set and frozen set, right? But frozen set is not possible because it's immutable. Similarly, removing elements, we will see how to perform this on set. It is not going to happen on frozen sets because frozen sets are immutable. They cannot be modified after they are created. We'll then look at some operations for checking for membership of certain elements in that particular data type, right? We'll look at some other set operations, which are very specific to sets like union, intersection, and so on. And then we will finally look at some additional operations. So let's start. A quick recap. What are sets? Now, sets and frozen sets, which is basically frozen set is an immutable version of a set, right? So we can just club it into one category, which is set. These are unordered collections that store unique elements, right? Even if you give it data which is not unique, right, which has repeating elements, what this will do is it will filter out only the unique elements and store it. And it will not be ordered, right? There will not be any meaningful order. It will be an unordered collection. These are powerful tools for handling distinct data and performing set-related operations. And we will see what are set-related operations in a lot of detail when we come to this section. All right. So let's have a quick recap. Sets store elements with unique data within them. These are unordered, right? And sets are mutable. That is, they can be modified after they are created, whereas frozen sets are not, right? So frozen set is a version of a set object which is immutable. It is still holding distinct elements, but you cannot add or remove elements after that object has been created. Now I'm initializing my set, right, as this. Remember, it is within curly braces. And if it is separated by commas, this is a set. If it has a key value pair, right, within the same curly braces, if you have key value pairs and you are separating them by commas, remember it is the dictionary. So dictionary is what we covered in the last session. So make sure you are watching that video if you are interested in learning more about dictionaries. So I am initializing this set, and this is an inbuilt object in Python, right? So I don't need to import any library, any external package, and so on. And I have initialized this, but notice that in this you have about 7 elements, and you have India and Poland. The two countries are repeating twice, right? So if I print my set onto the console, you will see that, you know, it only picks the unique elements. So India and Poland only occur once here. So that is how we can see it is only keeping the distinct elements. And also one thing more to note is note that the order is not preserved. So Poland came first in our definition of the set when we initialized it. India came second, Hungary came third. But when you see the set, Hungary is coming first, then India is coming, and then Poland is coming, right? So it doesn't have any order as such. There is no meaning of an order. And when we try to understand the type of the set, it is a set, right? All right. Now, how do you create sets? First thing, let's understand how do you create an empty set. Now, one thing which might come to your mind is, right, that you can create an empty set just by using the curly braces and not entering anything within it, right? Because that's the exact same way in how we create lists. Lists are basically created with square brackets and no element within them. But the issue with creating an empty set just by using curly braces is that curly braces are used not only for sets but also for dictionaries. So if I initialize something like this is actually a dictionary, not a set, right? It's an empty dictionary. So if I do type, this will not be a set, this will be a dictionary. That's why to create an empty set, you need to use the set operation, right? So that's why I'm initializing an empty set like empty set is equal to set. And this is an empty set now, right? And if I do type of empty set, this is a set. Now, what we just mentioned, if you initialize something with just the curly braces and no element within it, it is an empty dictionary, right? Okay, so this is a very, very subtle trick part of how do you initialize an empty set. Now, if you don't have an empty set, if you have elements, you simply mention the elements within the set and demarcate them by commas, right? So here apple, banana, cherry are demarcated by commas, and this is a set. Now, you might also think, what if I want to insert a list within a set? It's not possible because lists are not hashable. So you cannot insert unhashable objects or objects of unhashable data type into a set. It needs to be hashable, right? You might think, okay, what if I insert one set within a set? Will that work? Right? It also doesn't work because sets are also unhashable. They are mutable, right? That means they are not hashable. Now, if I do my set 1 is equal to, and if I do a frozen set within it, this will work, right? So I can initialize a frozen set like this, and then I do this will work because frozen sets are hashable. So frozen sets are not always hashable. In this case, because the elements of the frozen set themselves is immutable, it is hashable, right? So frozen sets are hashable in this case. So it works. So the main agenda behind explaining this part is that what are the restrictions on the elements you can insert within a set? And the restriction is it needs to be hashable, right? That is the restriction whenever you are inserting an element within a set. So make sure you understand that very, very clearly. Okay, so we have understood how do you initialize sets. And how do you initialize frozen sets? Like similar to sets, if you just want to initialize an empty frozen set, just call frozen set and the parentheses, so it initializes it into an empty frozen set object, right? The type is also frozen set. And if you want to basically create a frozen set of the set that you had defined earlier, right? So the set that you had defined earlier was my underscore set. If I can just do my frozen set is equal to frozen set and brackets my set, right? So it will convert that my set into a frozen set and assign that to a variable called my underscore frozen set. So you will see that frozen set has apple, banana, and cherry within it. Okay, so this is how you initialize frozen sets. And just one last caveat. So if you want to initialize a frozen set from scratch, you can do frozen set brackets, and then within the brackets you need to open the curly braces and mention the elements within it. So this is how you can initialize a frozen set from scratch. Okay. Now, how do you add elements? Now, sets use the add method, right? Now, it uses the add method to add an element to the set, right? So whatever the set name, then dot, and then the method name, which is add, and then also you need to mention the element which you are wanting to add. Now, we are calling, one small caveat is we are calling add as a method and not a function, because add is very specific to the object that it is getting applied to. In this case, you're applying the add method to a set. Now, add method cannot be applied in general to any other object. It can only be applied to sets. So it is a property of that set object. That's why it is called a method. In contrast, you have something called functions, which can be applied overall. right? So they are not very specific to the object that they are getting applied on. So there is a subtle difference between methods and functions, and we might use them interchangeably right now because we're just starting out in Python, but you need to be aware of this small difference. Okay, so this was my set. How do I add one more fruit to this particular collection? And I want to add mango here. Now, if I say my set dot add mango, right, and mango is a string because it's within the double quotation marks. Now, note that nothing has been returned in this cell. So it has basically changed the object in place. And if I print my set, it has become apple, banana, cherry, mango now. Now, if I do one more operation, I try to add apple, but you will see that apple is already existing in the set. So what happens if I do my set dot add apple? The set will not change because it only keeps the unique elements. So since apple is already there within the set, nothing will change and the set remains the same, right? Very simple. You just need one add method and you can add things to a set. And remember, whatever you're adding, the element needs to be hashable. If it is unhashable, that means it is mutable, it will not work, right? So you always need to add hashable data types within a set, otherwise it will not work. Frozen sets are immutable, you cannot directly add elements to them. However, you can always create a new frozen set with the desired element included, right? But you cannot change the frozen set itself. Okay. Now, how do you remove elements? There are two ways of removing elements from sets. Frozen sets, there is no method because frozen sets are immutable. In sets, you can use the remove method to remove a specific element, right? And the caveat here is if the element does not exist in the set, it will throw a key error, right? It will say that, this element does not exist. I'm not able to remove it. This is an error, right? So it will throw an error as well. That is, it will stop the code. If the entire code is running and there is an error somewhere in the middle of the code will stop running, right? So if you're using the remove method, make sure that your element exists in the set. So you need to first check whether the element is there in the set or not, and then only you need to use the remove method. If you don't want to do this kind of a double step, where you're first checking whether the element is there inside and then removing it, you can use the discard method. Now the discard method is similar. It doesn't raise an error if the element is not found, right? That is the benefit of using discard. It does not raise an error, right? If the element exists, it will remove it. If it doesn't exist, it will just keep the set as is. Now this was my set, and I do my set dot remove banana, right? So you will see that now banana has been removed, and you have only apple, cherry, and mango remaining, right? Now if I try to remove kiwi does not exist in the set, so it will throw an error, which is a key error that kiwi does not exist. How do I handle this? I can handle this kind of an error by using the discard method, right? So you can use discard in place of remove. If you are okay, right, with not knowing whether the element exists in the set or not, what you're actually trying to remove, whether it exists or not, if you're okay with not knowing that, it's okay to use discard. But if you want a condition that, this definitely exists and I want to remove it, always use dot remove, because if there is some error in your code, this will stop, right? If there is some error in your code and that element is not there as you expected, basically when you try to remove it, it will throw an error. So use it in that scenario. So if I do dot discard kiwi, nothing will happen. My set will remain the same, right? So it was earlier apple, cherry, mango. Right now also it is apple, cherry, mango. If I do dot discard cherry, it will work in a regular way. So it will remove cherry and the remaining set will only have apple and mango. All right. Frozen sets, nothing can happen because they are immutable. Okay, let's check for membership now. So sets and frozen sets. There is one simple operator called the in operator to check whether an element exists in the set or the frozen set. And the syntax is element in and the variable name of the set. So in this case, the variable name of the set is my set, and I'm trying to check whether apple is there in the set or not. And you will see that apple and mango both are there in the set. So if I do this, it will return true. All right, very, very easy, right? I'm using the in operator and I'm trying to check for membership. Now let's say I want to add something to the set and I also want to check the membership of that new element. So what I'm trying is kiwi in my set dot add kiwi, right? So my set dot add kiwi what will happen is it will return a none type object. So it will basically add kiwi to the set, right? But it is not basically returning anything. So when you do kiwi in myset.add kiwi, myset.add kiwi is basically returning a none type object, right? So this you will see that it throws an error, right? However, it is throwing an error, but it is still changing the underlying myset. So the myset now does have kiwi. So if I do kiwi in myset, it is true, right? Here it was not working. Kiwi in myset.add kiwi, because myset.add kiwi you cannot use in this kind of a statement, right? But what it did is, although it threw a type error, it still added the kiwi to the myset, right? So if I do kiwi in myset, it is true, and myset you will see becomes like this, right? So very important functionalities to keep in mind. You cannot do things like kiwi in myset.add kiwi, right? If you're trying to do this, the right hand side here, which is selected, right, which I've just selected, it needs to be an object on its own. But here it is an object of the type none type, right? Because you're performing an in-place operation on the set and it is returning a none type object. So you will not be able to do this, but it will still go ahead and add kiwi into my set, right? Okay. Why does it do that, right? Let's come to that. Because my set.add is getting executed first, and once that is done, then it is trying to execute the in operator, and the in operator is failing, but the first operation where it added kiwi, that is working. And similarly, there is the not in operator, which is cherry not in my set, which is again true. If I do apple, let me do this. If I do apple not in my set, it will be, what do you think? It will be false. Okay. Now let's come to some set operations, and all of these work for frozen sets too, right? These are common between sets and frozen sets because we are not changing the underlying object in this process. So frozen, it will also be applicable for frozen sets. Now set 1 and set 2 have defined two objects. Set 1 is apple, banana, orange. Set 1 is apple, banana, orange. Set 2 is mango, grape, and apple. Similarly, frozen sets also have initialized with the same elements, but now the only difference is the data type is a frozen set. Now the first operation is union, right? Union basically combines the elements from both sets, resulting in a new set with all the unique elements. So it results in a new set, right? So set1.union set2, if I do, right, I create a new union set object, and I'm assigning that to set1.union set2. What will happen is you'll see set1 has apple, banana, orange. Set2 has mango, grape, apple. So apple is common basically, right? And that will be just counted once. So your union set will become apple, banana, grape, mango, orange, just 5 elements, right? Similarly, I can do the same for a frozen set, and I'm doing frozen set 1.union frozen set 2, and I'm assigning that to a new variable union underscore frozen set, right? So this is also returning the same 5 elements, but now this is a frozen set type. Now what we just discussed a few seconds back, right? Here this is returning something. So can I do an in operation here? So can I do apple in this? Will it work? Right? It will work, because this is actually returning something. This right hand side is actually returning something. This is not a none type object. This is not a none type object. It actually returns a frozen set. So this will work. The in operator works, right? Something to keep in mind. Okay, now let's come to the second set operation, which is intersection. Now just as we thought about union, intersection is just keeping the unique elements which are common across both the sets, right, which are there in both the sets. And same syntax, you can do set1.intersection set2 and assign it to a new variable called intersection underscore set. And here you will see now set1, what did it have? It had apple, banana, orange. Set2 had mango, grape, orange. So the thing common between both of these is apple, and that is what gets returned here. Similarly, I can do an intersection frozen set, and if I do that, again I will get apple, because apple is the only common element within both the sets or the frozen sets, right? Okay. All right, let's look at another set operation, which is difference. In difference, elements that are there in the first set but not in the second, these result in a new set. So elements which are there in the first set and which are not there in the second set, that is what you will get as the output of the difference method. And I can simply do set1.difference set2. Now, can you think what will happen? I'll pause for a few seconds. If you do set1.difference set2, what will be the output? Things which are there in the first set but not there in the second set. Okay, the answer is banana and orange, because apple is there in both the sets, right? So if you're doing set1.difference set2, you are getting banana and orange because it's there in set1 but not there in set2. Similarly, I can do the same for frozen sets and it behaves the same way, right? The only difference is that the output is a frozen set object. Now, this is called difference. But sometimes you might want to say that things which are there in one set but not in the other, and things which are there in the other set but not in the first set. I want to have the entire set, right? What is the entire collection which satisfies this condition? So there you can use a symmetric difference, elements that are there in exactly one set but not in both, right? And this is what symmetric difference does. So you can call a symmetric difference. It will basically not consider, which set is coming in the beginning and what set is coming in the argument of this method. It will just take a symmetric kind of a difference and it will apply that condition to both of them, right? Elements which are there exactly in one set. So I'm assigning set1.symmetric difference set2 to a new variable called symmetric difference. And you will see banana, grape, mango, orange are coming. Now, why is this coming? Now, banana orange is coming because that is coming from set1.difference set2. From set2.difference set1, what will you get? You will get mango and grape. And the union of these two is what you will get as the symmetric difference. So what is actually happening? How is this working? How this is working is you first do a set.difference set2, right? And you union this. So I'm doing a dot union with set2.difference set1. And if I do this, is same as symmetric difference. This is true. This is what is happening with it beneath the hood. It is doing a symmetric kind of a difference. It's not making it very hard and fast rule that what is coming outside and what is coming inside. It's taking a symmetric kind of a difference, right? So I hope this concept is very clear. Let me repeat it. Elements which are there in exactly one set but not there in both are captured by the symmetric difference method. How this is working beneath the hood is it is first calculating set1.difference set2 and unioning that with set2.difference set1. And that is the entire collection that symmetric difference returns. Okay. Now, just a few checks. If you do set1.difference set2, that is not equal to set2.difference set1. So if you do this double equal to operator, this statement is false. However, if you do set1.symmetric difference set2 or set2.symmetric difference set1, this is exactly the same. These both operations will return exactly same outputs. So this is true. And similarly, this can be done for frozen sets also. So I've included this for reference. And you will also see that Python does not make a difference between sets and frozen sets when it is comparing them. When you're using the double equal to operator, as long as both the frozen set and the set have the same elements, this double equal to operator actually returns true. Why? Because frozen set is still a set object under the hood, right? So it is still an object of set type. And the only difference is it is immutable. So Python does not actually give weightage to that difference that it is immutable. It still considers them both equivalent, right? And I'm again checking this. I'm creating a set on the left hand side as apple and banana and a frozen set with apple and banana on the right hand side, and this is true. All right. Now, two other methods is subset and superset. And you can use the method isSubset and isSuperset to check if one is a subset or a superset of the other. What do we mean by subset? Now, set 1 is a subset of set 2 when all the elements of set 1 exist in set 2. right? And set 2 becomes actually a superset of set 1 if all the elements of set 1 are available in set 2, right? So when you're thinking about subset and superset, if A is a subset of B, it automatically means that B is a superset of A, right? So make sure you are understanding this very, very clear definition. Now I'm defining a new set 3 as apple and banana. And I had my set 1 as apple, banana, orange, set 2 as apple, grape, and mango. I'm trying to check whether set 3 is a subset of set 1. What do you think? Apple and banana, and set 1 has apple, banana, orange. So that is true. So it will return true. Similarly, I'm checking whether set 3 is a subset of set 2, and that is not true because banana is not there in set 2, right? So this is false. Similarly, now if I check if set 1 is the superset of set 3, that is right. So this is just the inverse of this. Set 3 is subset set 1, and set 1 is superset set 3. These are equivalent kind of statements, right? And similarly, if I check set 2 is superset set 3, this will be false. All right. Now let's come to the last operation that we'll be discussing today, which is the clear method. And again, this particular clear method will only work on sets because this changes the underlying object itself. So it removes all the elements in the set. It is not applicable to frozen sets, right? So if I do set 1 is apple, banana, orange, I do dot clear, it will basically clear the underlying set. And if I say set 1, it will basically show me an empty set now, right? Because set 1 dot clear has actually cleared all the elements in the set. Similarly, if I have a frozen set like apple, banana, and orange, and if I do frozen set dot clear, it will say that the frozen set object does not have the attribute clear, right? Because it is immutable, you will not be able to clear it. So this is all about sets in a nutshell, right? It might seem a lot, but this is actually a nutshell. And I will be sharing all of this material in a PDF format in the comments. So make sure you're checking this out, going through it line by line and understanding what is going within it. And if you have any questions, feel free to put them in the chat. I will again remind you, make sure you're hitting the subscribe button and hitting the bell icon for notifications whenever we go live every day at around 10 p.m. Right? You will get a notification about it and you can join the live session for more engagement and more clarity, and you can paste your questions live in the chat as well. So stay tuned. I'll see you tomorrow. That is all for today.